Hello, hello. Welcome everybody. All right, so welcome to the stream. For those of you who are new here, my name is David. I do these Rust live coding streams about once a week. And for the past 2 weeks, I believe, we've been slowly sort of building up the backend for a Twitter clone in Rust. The idea is to build an app completely in Rust, so a web app that is, with the backend in Rust and the front end in Rust as well, using WebAssembly. And we've gotten a fair bit of the way with regards to sort of setting up the skeleton for the web app. And today I expect that we're going to sort of clean that up a bit, pull out some reusable pieces, maybe test some edge cases around our authentication, which is what we were working on last week. And then I expect to dive a little bit into the front end just to sort of verify that the setup that we have actually works, or if we need to make any changes. It would be annoying to sort of build this entire backend only to realize that there's actually something that we didn't consider at all, which makes it not work with the front end. I don't expect that we're going to run into any problems, but we're going to see how it goes. So to sort of introduce you to the backend that we've been building so far, it's in Rust, and we're using the async await feature. We're using the Tide web framework. We're using SQLX for database integration stuff, and we're using Postgres as our specific database. The rest of these traits are not really interesting, I think, but this is sort of what our stack looks like so far. If we take a look at our main.rs, it's pretty much everything in one function. This server function that just constructs the Tide web server that we're using. It defines our routes and it defines the handlers for each route. So what I think we're going to look into today is sort of clean some of this up. Currently our serve function is like almost 200 lines, 176 lines. Hopefully we'll be able to clean that up a bit and sort of provide a bit more scalable structure. We also have these different responses down here, which are currently just sort of ad hoc put here in this file. I'm thinking maybe we can pull them into some other file. What I think would especially be cool is if we'd be able to reuse those same structures on the front end to make sure that the responses and the requests are sort of aligned in that sense. That would be kind of neat. Otherwise, we're just currently doing most of the sort of stuff that needs to happen directly in these handlers. For example, there's the one you can request /me. That's how you get data about the current user. And all the authentication code is currently just directly in that handler, which we're probably going to want to pull out. That's one of the things that we want to look at today. We can dive into the tests that we've been writing so far. We have just sort of enough tests to make sure that things are actually working. We have a test that tries to create a user with a username and password, and then tries to, again, log in as that user, basically, or make a request to authenticate as that user. And that works. And then we have a couple of error handling cases, I believe. There's one if you log in with an unknown user, and there's one if you log in with an invalid token. That's sort of what everything looks like, and we can of course run the tests and make sure that they all pass, which hopefully they do. There we go. You may notice that we get a whole bunch of output from like logging output. That's because currently we've set our default logging log level to trace. I think we can just set it to debug. Then our tests are significantly more quiet and there's a bit less noise. If this turns out to be a too high level and we need more information, then we can always tweak it from that point on. So that's sort of the setup so far. I think actually what we're going to want to do first is pull up the Tide documentation and try to figure out how we can actually pull out this authentication logic. So let's do that. I have a web server running that just compiles the documentation for all the libraries in our crate. And actually, now that I think of it, there's one thing that we should do first. So last week, if you go to the Twitter repo, there's actually a guy who opened an issue, which is very nice. So we were struggling with, if you look at the authentication library that we use, this one, it's the one that basically hashes the passwords into a one-way hash. That's what we store in the database. And then it's the library that will basically verify a hash against some password from the user. And if you look at their hasher, it has one called hash non-blocking that returns a old future, so it returns a 0.1 future. What we want is use the standard library future, and specifically to do that, you have to use if you look in futures, you have to use the compatibility feature that they have. And we were struggling to get that working last week. And what I have realized since then, and what is also mentioned in this issue, is that there's actually a feature flag that we have to turn on for this feature of futures to be working. So what I noticed was that there was like this compat module here, and I was like, let's use it. Futures compat, and it said it couldn't find it, and I was like, what the hell, why not? It's right there, what's going on? I don't understand. Turns out that it says right here that this module is only enabled when the compat feature is turned on. And I believe because if we only looked at our local docs last time. And I believe because we haven't actually, so in our cargo.toml here, we haven't actually added that feature when we installed the library, which means that the compiled docs that we see here don't actually include that module because, well, it's not compiled in. Whereas the version of the docs on docs.rs are compiled with all features enabled by default, I believe. And there it is. So I think by adding this this feature and then recompiling our docs, we should be able to see it. So currently the way we got around it was to use spawn blocking, which basically just spawns a blocking task on a special thread pool. So like this approach works just fine, but I think using the compatibility feature thing is a bit more of a nicer way to go. So if you recompile this, it should work, and it totally does. So now if we recompile the docs as well, we should see the futures compat module in our docs. While we wait for that, basically they have a struct called compat 0.1 as 03 that basically takes a 0.1 future and converts it into a 0.3 future, which is exactly what we need. So there we go, the docs are back. We should be able to refresh this one, and now we see the module there. Another crate that I also recommend you check out is called cargo what features. What features, and you can say like futures, and then it shows you all the features that futures have. You could, if you wanted to, like go into their cargo.toml file and see it. I'm not sure they mention all the features in their README. No, it doesn't seem like it. And this is at least a nice way to see it. And then we would have noticed that there's a compat feature right here. So let's see how to use it. It's this one. And then, so we should be able to do that. And then say this is, that's the verifier. Let's do the hasher first. There we go. So this should be hash non-blocking. Put that in a new. I'm not quite sure where this map error thing needs to go. Nuke that one. Yeah, and hash non-blocking just returns a future, so our map error probably needs to go here. Like that. And there we go. So this thing on the inside returns an old future. We convert that into a new future by basically wrapping it in this compatibility layer. We call await on it to get the result of the future, and that is, well, the output of the future rather is a result that we have to convert to the correct error type. And the reason that we're doing compat here again is that this error type is unknown. Thank you, Rust Analyzer. It's a failure, I believe. If we just look at their error handling, hash non-blocking error. So it implements the fail trait from failure, which is sort of a deprecated way of doing error handling in Rust. You notice that, let's see, it implements fail. So fail is from the failure crate, and it actually doesn't implement std error trait. So we can't just trivially return it from a tied endpoint or handler, but they have this compat function, which is what we're calling here, that returns a compat error basically that does in fact implement the standard library error trait. So that's what we're doing. It's a bit unfortunate that we have to do this. It would be cool if someone were to submit a patch to this authentication library to update what futures version they're on, and also what error handling library they use. It should probably move to either this error or anyhow. So if you're looking for an open source contribution to make, I think that would be a nice one. Let's just do the same one for the verify. So create the verifier. This one goes out there. Map error goes afterwards. And then we have this. This is verify non-blocking. I believe that's it. Still compiles. Let's check that the test will work. And they do. Great. Let's just commit that. There we go. All right, so let's try to think what to do next. I believe we did have a to-do list. Let's see if there's anything obvious here. Map invalid data error to some 400 response. I think that's because here in the post to /users, where we create a user, we deserialize the response into a create user type, and the deserialization is done with Saturday. And I believe if this fails, it'll return a 500 response rather than 400, which it should be because it's a client error, right? I think the very first thing we're going to look at is how to pull out the authentication stuff. You can imagine that we're going to want to authenticate for a lot of endpoints. So I think that's the kind of thing that makes sense to pull out into a function. So if we look at tied, I do believe what we're going to end up using is a middleware, perhaps, that will sort of check for the authentication header being there, and if it is, and if it's valid, it'll set the current user as a variable on the request. So if you look at the tied request, they have a thing called request local state, I believe. Set local. I guess there's also local to get a local state basically, and this is how you can sort of get like we can save a current user into the request, and then in the middleware, and then in the actual request body we can get that back out. You could also not set it in the middleware and just sort of do it up front when the user asks for it. I actually think that's the nicest way to do it first, and if we notice that we do it multiple times within the same request, then we can pull it out and do it into a middleware. So how do we do that? Let's see. We could basically pull, let's see, what do we actually do? We get the header, we parse it, we query the database, that returns a user. Yeah, so when you authenticate as a user, when you log in or you create a session basically, you get a token back, an auth token. And so we get that auth token out of the header, and if there's a user with that particular auth token, then that's the user you get, otherwise you get nothing. So we could basically make a function that takes the request and returns like an option user or an error user, a result, if there's errors, which there can be, it seems. No, these question marks are for unwrapping the optionals, I believe. The error handling is basically done in that if the header is invalid, we return a bad request. If the header is not present, we also return a bad request, I think. Yeah. I mean, the database query could fail. I think we should just try to pull it into a function and just see what happens. We could call it authenticate. Takes a request. It's an async function. And let's just say it returns a result. What error type do these return? Endpoint. I think it's like an HTTP result kind of thing. So this is the get method that we're calling right here. And then I'm like, what does that take? That takes an endpoint, well, something that implements endpoint. Endpoint has one function that is a call that returns a future where the output is a result. That's a default to response and an error. So we have to return either a user or this one. Let's try to pull this in. Can we just copy that directly? Nope. Right, so up here we're only returning a user, whereas the endpoint can return it returns a result. So that's because we return early here. I think we have to convert these into error messages. Like do something like this. what I'm thinking is we need to make sure we have test coverage for these paths. So let's add a to-do here. Let's first verify that all the tests will pass. They do. Now there should be some test that fails. And there's not. Great. I think that's because we test that we get the header and then we get the 0th value for that header. So if you pass the header multiple times, then the header will be set multiple times. That's why you have to say this like get method on the header values. So that would be if the header is either not there or is, yeah, don't we have a test for that if it's not there? Logging in with invalid token. Logging in with unknown user. No, I think we only have a test for the happy path, basically. Yeah. So I think we're going to want to add tests for these two failure cases first before we start pulling it out, just to make sure that we don't break anything. So let's say this is an async test. Oh, what just happened? Logging in without auth header. And the other one that we're going to need is logging in with invalid auth header. Let's see. So we create the user, and then we log in. Then whatever this request returns should be a bad request. What HTTP code is that? It's a 400. Run the tests. It should fail because we haven't really changed anything. There we go. So if we remove this header, so this is the call that creates the user. We still want that. We don't need this one. This one is just to verify in the previous test that there are no users to begin with, which we don't really care about for this test. And that passes. Let's just make sure they can actually fail. So I think that should be this one. There we go. It panicked at 139. 139, that's right here. And if we return a different one, is there? I'm a teapot. Let's return that. And if there's any questions at any point, just put them in chat and I'll get to them. Right, so the test is actually working. So it expected to get I'm a teapot, it expected to get a 400, but it got I'm a teapot. So if we replace that, it should still work. I wish the tests were faster to run. It's going to be quite tedious to have to wait for them all the time. All right, so now we need a test for this one. Let's first verify that we don't have a test hitting it already. Which we don't. Great. So that should be this one. That's quite similar. We do want the header, but let's just write foo here, so it shouldn't match the barrow token thing. Now we do want the token. How do we pull that out? Let token. Like that. if we change this one, there we go, the write test failed. Logging in with invalid auth header. Change it back. There we go. So now we successfully have coverage for these two failure parts as well. So now we can actually start pulling it out. Let's do this. So this one should be, I wonder what we can return here. Endpoints. Any error. Status code. You can create an error from anything that implements the standard error trait. So it would be convenient, right, if we were able to return something like anyhow error like this. But as we've seen previously, we can't actually do that, which is unfortunate. The reason is that the anyhow error doesn't actually implement the standard error trait as ref static. No. Is there a way to get around that? To basically return a... Because it kind of seems like that's what they're doing here, right? All right, let's try to call it. Let user authenticate with the request. Await. Yeah, so it doesn't work because anyhow error doesn't implement standard error. Can we do something like this? Root cause downcast. I'm not quite sure what this syntax means. Nah. I'm not quite sure what we're doing. Does that mean we can't use anyhow error at all? This is not quite what I was looking for. I bet if we were to return something like assume this would work. Yeah. What's the error now? Cannot be known at compilation time. Do we have to make our own error? I wonder if Tide on their GitHub page, if they have some examples. Like, we can always use what's it called, this error to sort of generate our own error. You know, it just seems something like this, right? It just seems a bit annoying that we have to do that. Do they have examples? GraphQL. Handle GraphQL. They don't seem to have any like helper functions that they've sort of pulled out in the same way we have. Vip. What the hell is that? Tide results string? No. Cookies? We could obviously convert the errors into these HTTP errors. That is probably what we're going to want to do. I just wonder if that's going to get tedious over time. New a status code and an error. I don't really have an error that I want to use. Guess we can use anyhow here. Which we can't because it doesn't implement standard error from stir. All right, that works. I wonder what it returns in the body though. What should we say? We should say missing value for authentication header. Do similar thing down here. And this is unable to parse authentication header value. All right, so all our tests should still pass. Hopefully. Did they pass? Yeah. Huh. I mean, it does make sense that it logs it, right? It just almost seems like there's a bug in our implementation, which there isn't. There's a bug in the client. But the tests do pass, so we didn't break anything. That's nice. I do imagine that this sort of business is going to be annoying. Oh well, let's keep it for now and just see if it turns out to actually be annoying. Let's add a use for this one. Like that. Is there anything else in here that we want to pull out? Maybe this stuff to actually like pick out a header would be nice. Let's do that. Request takes a result string. I'm not quite sure if it's going to be a string. Expected struct found stir. That works. So I guess this works because the request lives for some lifetime, and then when you actually borrow the header, you borrow the header from the request. So that makes sense. If this was like an owned request, we wouldn't be able to return a borrow string from it here, because then the borrow string would outlive the request itself. We should, however, say, so we have a header key. Right, and now, so notice previously it was able to infer that the anonymous lifetime that we have here corresponds to the anonymous lifetime that we have here. And that's obvious because there's only one lifetime involved. It couldn't be anything else. Whereas now that we have two anonymous lifetimes, if not sure if this string is borrowed from here or from here. So we have to tell it that it's actually borrowed from here. I wonder if you can just use like this, or if you need to actually name the lifetime. Nah. So it doesn't actually matter what we name it, it just means that this one lives at least as long as A, and A is this guy. So this is basically a way of saying the return value of this is borrowed from the request. We just need to put the key in here, like that. And then we should be able to call that instead. Get header. Like that, very nice. I do wonder what the response actually looks like. Let's try to fire this one up on curl. What does it run? 8080 / me. right? So it just returns a plain text where that is actually the response. Should probably make that some JSON thing. We can't set a content type though. And it didn't have one, right? Oops. No. It just has a content length. Content type text plain. Can you set a content type for errors? I'm wondering if we didn't use their HTTP error thing, but instead had our own error enum, can we make a middleware that catches, so it takes any error. Let's see, next, you can call run on it, get a result back that returns an error, and you can downcast that one to our own error type. And then we can set the response body from there. I do think that would be nice to have a test for. Log in like that. How do we get the JSON back? I did that like so. And I wanted to have, say error, whoops, message, like that, missing value for authentication header. So this should fail now. I wonder if we can get headers on the response. Yeah, so it failed because we call result unwrap on 73. That's here because it couldn't parse it into an actual body, into a value rather. I wonder if you're able to get the headers as well. I would like to make sure that it has the right content type. What type does response have? It is a HTTP types response, which is not there. HTTP types response. Get a header. Header authentication. Turns an option. It has to be a header name. It implements from stir. So any type from stir is a trait from the standard library. It's basically like a parse trait, so things that can be parsed from strings. And it works with the parse method on stir. So anything that implements from stir, you can call parse on, which means that's actually, I believe that's exactly what we're doing here. Like that. And it has to be a reference. Unwrap. It still has to be a reference, right? Yeah. So that gives us a header value, a vec of header values. We get the first one. Header values implement as stir. But it's not the authentication header we care about. We care about content type. Should be application JSON. And as we just saw in curl before, it returns text plain. We actually want application JSON. So that was the middleware. So let's see, we do actually have to make our own error enum now. Wonder if there's an easy way to do it. If we can like make one that wraps an anyhow error. That would be quite convenient. Let's give it a shot. So if we make just try to make a new module. Use anyhow error. No. Say we have a struct error that has an anyhow, and we want to implement display from the standard library. I can never remember how to actually implement that. Like that. And can we then implement from any E into our error where E is a std error? Yeah, you sometimes get these. It would just be really nice if we could make it work with from, because that means that we could use the question mark error automatically. But it doesn't seem like we can, because there's a blanket import for in the standard library to basically convert a type T into a type T, which you often run into actually. I wonder if there is a nicer way to do it. Do we really have to make our own error enum? All right, let's try to do that and see if that works. So that means we need this error, which we already had. Sweet. Looks like this. Waiting for file log on bill cache. All right. Yeah, we've already imported HTTP error. So let's just say import that one as HTTP and then rename this one, because we're going to be defining our own type with type that has the name error. And it needs to derive this error. And then it definitely needs to, be returned there. Let's just put this function below. Let's verify first that we can actually get it working before we start converting all the error handling stuff in here. So this just returns an error. Did that continue to work? It did, because it does, this error type does implement standard error, which means that we can now, hopefully, convert this guy from a HTTP types error. That's because the get header still returns the old error. Let's just focus on one at a time. From stir is not implemented for nothing. That's because we need to parse it into a header value. So it implements from stir where the error type is an HTTP error. Does that mean if we say I believe you can say error transparent. Whoops. Get our syntax right. As din error. What the hell? This one doesn't implement standard error either. why not? Because it has the same one. So this is basically the trait implementation that we tried adding before, which we can't do. And I suppose the reason is that we're getting this error is because this error only supports wrapping things that actually contain, or rather things that actually implement standard error. Wait a second. Status. This one, it doesn't have a way of getting the message back out. I actually still think that we can use the middleware, like make the middleware that correctly sort of sets the error response. I just think that this has to be our error type because we are able to get the message back out. That's basically what the display implementation returns, right? So it just displays self.error. And if we scroll up, we can see that self.error is basically an anyhow error. So I think that we basically undo all the stuff that we just did. And this needs to be HTTP error like that. I think we're back to working. And then let's try to add the middleware, because we can just, the error that we get, we can probably just still change the response, I'm thinking, from within the middleware. How does middleware work? Do we already have one? Didn't we have like a logging middleware or something? Nope. They can be applied with server middleware. Takes a thing that implements middleware and debug. Let's make one called, what should we call it? Map error response. Error response to JSON. We have to implement middleware for it. And next is there. Pin is from the standard library. So is future. So now we should be able to add our middleware here, like that. Expected server found mutable reference. I think middleware is just supposed to be called like that, similarly to defining the routes. So if we add, right, everything should basically fail now. That should sort of show us that the middleware is actually there, right? Yeah, so that's this one. So if we just say next dot run CX. So now everything should work. So it's basically middleware that does nothing. Yeah, and this is the test failure that we were getting before. So now, so next returns a future that returns a result, where the result is either a response or an error. Like that. So if actually handling the request succeeded, then we don't really need to do anything. So we just pass along the response. If we get an error though, then we want to return a different kind of response. I think like that. Yep. Probably with the same status, right? How do you set the body? Dot set body. Is there a JSON thing? Body form, body JSON? Or does that return the body? Encode a struct as a form and set that as the body. Just go back to the reference. I believe we can just inline it like this. Yeah. So this question mark is in case it fails to actually convert this guy into JSON, which it shouldn't at this point, but it might. And that's because we have a lowercase m. Notice the very first assertion with the content type did work. So there we go. We're now correctly setting the JSON body. I suppose that if we're going to want to add like any additional sort of error data stuff here, then we're going to need our own error enum somehow. I'm not quite sure how we're going to handle that, because then we're going to run into some of the same issues that we've had so far. Anyway, I actually think this setup is fine. Let's see, is there anything else that we're going to want to pull out? I mean, this stuff to get a database connection pool. Hey, New Duck, how's it going? This stuff to get the database connection pool out every time is sort of annoying. We could make a small helper for that. I think having to type. Oh yeah, we wanted to make actual sort of structs for this setup, because currently we're repeating this data stuff every time, right? You release version 3 of your web app. What sort of web app is that? Yeah, I think we should make our own like response struct that has a data field and then some generic serializable thing on the inside. Sand falling, physics sandbox. That sounds complicated. Ah, cool. Right, I've never done anything like that. Sounds cool. Rust isn't looking fun. It usually is pretty fun. Sometimes you struggle with stuff. I mean, I guess we could file like an issue on the Tide repo to be like, how do you actually expect us to handle this sort of case? I've written with the creator of Tide a bit on Twitter, and he seems like a nice guy, so I'm sure he'd be willing to help out. All right, so I imagined for this guy, we're gonna have some like, what do we want to call it? API response, JSON response, data response, API response. Like that. And then for this one, the actual token response, we'll just call it token response with a token that's a string. And now we should be able to do API response, data, token, and that's because we need to derive serialize down here. There we go. It should still pass. How's it version 3.0 of your app if you only started on Monday? And you're fast. Doing this every time this app responds new, like manually declaring it like that every time is a bit annoying. Let's add a new impl API response for T. I lost track of my parentheses here. And we need a question mark here. No, here, I believe. Yeah, because in case converting it into JSON fails. Right. Let's also add a new for this one. So that becomes new token, like that. Very nice. We could technically do something like to response, right? Possibly with a status code. I think that'd be nicer than the other way around. So that means we want a fn to response. Probably also want where t is serialized. It doesn't take the status. Is it tedious that we have to wrap our sort of lower level responses like token response in an API response every time? What if we could just do this? And then this sort of wrapping would happen implicitly. I kind of like that. So it just does API response new self. It's already quite a bit nicer. We could even have like a default one. So we could rename this one to be with status. And then we could have one that doesn't take a status, but defaults to defaults to using 200 OK. That. Wait, what's it saying? Because we added the question mark there, which we don't want. Yeah. So we technically don't need the OK wrapped anymore, because this already returns a result. Let's just put, so we're currently getting a warning that the method isn't being used. That's fine. Let's just say allow dead code. Same here. All right, so that's already quite a bit nicer, I think. Let's use the same pattern here. It's actually exactly the same. It's just token row instead. Token row, like that. And this one, we do need, now that I think of it. So up here, we're gonna need a new like low level response, right? We're gonna need like a user response kind of thing, but it's quite tedious having to implement both of these methods again. What I'm thinking is that we can make them generic and like implement them for any type that implements serialize, because that's technically the only requirement that we have here. Yeah, let's do that. So the way that you can implement types, basically add methods generically to anything, is to make a trait that have those methods and then implement that trait for like a generic type T that has some constraint. So we could say trait build response, build API response, and it would have these methods. We can say it's a super trait of serialize or a subtrait of serialize, I think. Yeah, and the reason we need sized here is because we're taking self by value. I think the compiler was actually also telling us that. Yeah, so it says this size of self cannot be known at compile time, because if you're taking self by value, you basically need to know how big the type that's implementing the trait is, because Rust needs to know how much space it has to make on the stack. Whereas if it's a borrow self, like a reference, then it's just a pointer, and the pointer always has a fixed size. This gets into object safety and that sort of stuff, which is a bit out of scope for this video. But basically we do what the compiler says, and says you have to be both serialized and sized. I wonder if that is enough, actually. No. I think if we say, though, impl trait build response for T, where T is serialize. There we go, it now works. which is kind of nice. We don't have to add those methods every time. So we can now make a user has an ID and a username. ID is a UUID, I believe. His name is just a string. And it takes a that's because the UUID type is called like this. We do have a user struct, I believe. Yeah. So now here we should be able to say user response from the user, like that. Very nice. That's already quite a bit shorter. Let's just run the test to make sure we didn't break anything. We didn't. Are people following this sort of way of handling the duplication and why these methods show up just sort of magically for the user response type? Does that make sense? I asked a couple of weeks ago on Twitter if there were any topics that people wanted me to cover, and some people said they wanted me to talk more about generics. So if this is not clear to you, let me know, and then I'll go into more detail about it. Do we have any more hard-coded responses? We do up here. We return each user. The user type already implements serialize. That means we probably don't need this type at all, actually. Oh, that's really cool that we can just do that. I didn't even realize. And the reason that works is because the user struct that we made before already implements serialize. So this just works. So up here, we're returning a list of users, I believe. Yeah. Which means that we want our response to look something like this, where this thing in the middle is a vector or a list, and then here we have the ID and the username. I actually think our test might be missing. I mean, it is a bit silly that we have an endpoint that returns all users. I think we should just remove it. The reason that we have it in the first place is way back when we started, we had some issues with state being left over in the database after tests. We don't have that problem anymore. Is this test still valuable to have just to ensure that we don't get it back? No, I don't think so. I think we should just remove it. That means we can also remove this. All right. Let's try to start actually pulling stuff out. So what do we have? We have handlers, and we have basically inputs, you could say. And then we have almost like models. Basically the user thing is almost like a model, right? Should we call it a response? Let's first remove these imports here that we aren't actually using. Let's say we have a mod responses. And there this guy is. And these are as well. Let's put this one above the token response. We need serialize. We need the response, status code, error, and then we say use responses. See, we need to make this one public. Basically everything needs to be public. We need UID as well. And we need the build API response. New is private. We need user. There we go, back to compiling. Serialize we don't need. All right. Then let's make a module called like handlers or something. Oh, we don't need deserialize from here. And let's just pull these in there. Now I'm using Rust Analyzer with Vim, and it does have a feature where it's supposedly able to auto import stuff, but the Rust plugin that I'm using for LSP doesn't actually work with it. I'm not quite sure what's wrong. So for now we have to do the imports manually. It's a bit tedious. I'm hoping it's going to be fixed at some point. Is that it? Almost. I have to use it. Use handlers. Authenticate. And back. This one we don't need. Is it the user that's not being used? Yeah. All right. How do we want to pull these guys out? Let's find a smaller one first. Let's try to find this one. So the get method has to take something that returns an endpoint. Let's look at endpoint. I suppose we could also call this module not handlers but endpoints, just to sort of stick with the tide. Naming. So it has to have a call method. It's implemented for any function that takes a request and returns a future. Let's just try to make one called get me. Takes a request. State needs to be an async function, and it returns a tide result. Does that now mean that we can put this one, get me, like that? That's pretty convenient. Yep. So I'm thinking that our handlers are basically just going to look like that, unless they need any like. Although, I suppose it would be nice to have them be like me : get like that. So these are actually namespaced. Yeah, let's do it like that. So in handlers, let's say we have a mod me, or an endpoint rather. Let's move this file to mod.rs. So in Rust, you have two different ways that you can specify your modules. You can either do it where, so I have a module called endpoints. Then you can either in the source folder have a file called endpoints.rs, or you can have a folder called endpoints with a mod.rs folder inside it. If I don't have like child modules inside of my endpoints module, then I prefer to just have endpoints.rs in the root. That's a bit easier. Whereas if I do have multiple child modules inside of endpoints, I prefer to have this structure where you have the mod.rs, but it's entirely up to you. This just means that when you look at the file tree, all the files will be in the same folder. So we say we have a mod me. That has this function inside it. endpoints. We should now be able to say endpoints me get me. Let's make this a struct me. It's not really better, is it? Like, we could as well have it like this. I think that's fine. No reason to nest things further into structs than necessary. So what else do we have? We have a users. That is a create. A bunch of missing things. Let's just see if we can have Rust import help us with most of them. I wish there was like a way to just import all the missing things. That would be convenient. Wonder why it's not telling us like the path to the things that I'm missing. Is that because query macro is messing things up? No. Where did the hasher come from? So this env module is not the env crate in the standard library, but rather the env in our own crate. This guy. Almost there. And we're now compiling. So now we should be able to replace all this with endpoints, me, users, create. Very well. We're not using authenticate. Let's just indent this one correctly. Nice. Let's pull this one into the same module, the login. Just make one called login. Where's password coming from? Root. Response is from Tide, I believe. Verifier is from the same place as the hasher. And there we go. So this is now endpoints, users, login. Very nice. That has cleaned up the building of the server quite a bit. Great. I think it makes sense to move this one in here because I don't really expect us to be using it outside. Like that. Probably the same with the password. We use it just for logging in, not really anything else. State is fine to keep. There's so much we can clean up now. That's great. We could make a module called like middlewares or something. I think that makes sense. Didn't we have like a use for pin in future? Like that. Very nice. This is quite a bit cleaner. Cool. I think that looks pretty good. Yeah, that's much nicer to look at than the huge file that we had before. And everything still works. So that's the sort of wonderful thing about Rust, right? Is that you can just like move stuff around willy-nilly, and when everything compiles, it probably still works. That's true for most compile languages, but especially so for Rust. Let's go ahead and commit it. What did we do? We did some... I should have committed more. Did a whole bunch of stuff. Fix error handling, bugs, and cleanup. Handling, bugs, and cleanup. All right. I actually think that is, let's look at our to-do list. So that one we did fix. That was the future error that we talked about way in the beginning of the stream. I think we should probably tackle this one as the last thing, and then probably move on to the front end. Although, no, let's just move on to the front end right away. So, very new to Rust here. These streams are great for getting a sense of it. Yeah, thanks. If there's anything specific that you want to see, just let me know. Actually, I'm out of water. Let's take like a 2 to 5 minute break, and then we're going to dive into some WebAssembly afterwards, which is going to be exciting. So I'll be back shortly. All right, let's move on. So WebAssembly, huge disclaimer, I haven't done any front development for like 5 years, really. I've had 2 jobs in the past as a front developer, so I do sort of know what's going on. But since the whole sort of JavaScript ecosystem basically exploded with React and all the things that are going on now, I haven't done any of that. I've done a little bit of Elm, so I sort of know the concepts of like these sort of component-based like front-end frameworks basically. So I'm probably going to struggle with a bit of this. Hopefully chat, you'll be able to help me out. Great to see that there is a front-end developer here. That's very convenient. There are 2 sort of main front-end frameworks that I've been able to find in Rust. The first one is called U. I think that's how you're supposed to say it. And the other one is called Seed. I did a bit of playing around just before the stream, just kind of seeing which one was easiest to get started with. I don't think either of them are really production ready yet.